And welcome back. All right, Nelson, let's go ahead and continue.
Alrighty, so the last thing we have to do is actually make our value builders build something, because currently they really don't. But before I do that, I want to go ahead and show something cool. I want to go ahead and I'm just going to put a breakpoint right here in our run method, and I'm going to pass in this input right here into our Antler file or into our Antler generated classes. And then you'll remember right here we do parser.run, which is going to invoke the run method. And be sure to remember that this is a partial for our basic JSON parser, which is the class that Antler generated. So I'm going to hit F5, and I'm going to hit F10. Now in my watch window, I'm going to do this. I'm going to type in our underscore builder, because remember, we have this underscore builder field on our class that is now filled with a builder. So then I'm going to hit enter, and hey look, we have an object builder, because remember, the first thing in this file is an object. Inside of our object builder, we have a one item with the key of hey and the value of an array builder. And inside of our array builder, we have three items, which should be 1, 2, and another object. And you see constant builder, object builder. So this is going to have the value of 1. This is going to have the value of 2. And inside of our object builder, we will have another key value. So that should be whoa. And you see right there it is. And then under the value should be another array. And you see that it is array builder. And our array should have three items, 4, 2, and hey. And it does. It has three constants, which is hey, 2, and 4.
Very nice.
So you see we now have this nice hierarchy of these object builders, but we want to actually turn these into values that we can consume in C#. What I did, or what we're going to do, is we're going to build a value impl. I'm going to go over why I called that impl in a second. That's going to implement iValue. And iValue is going to be, we're not going to if we went to the DLR now, we could actually make something really cool. But instead, I'm going to make the interface into our JSON data very, 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 very simple and straightforward. So that means our iValue is actually going to be capable of representing a constant, an array, and an object. And so let's go ahead and implement our iValue. Our iValue is going to have two private fields. One private list of iValues, and this is going to be our values, or sorry, our array, or something. Call it something. It's going to be read-only as well. Well, don't literally call it something. The second thing, we're going to have a string dictionary iValue, and we'll call these object. Then we're going to have three constructors.
You might want to check the spelling on object.
Okay, there we go. Spelled right. See, the problem is I wouldn't have noticed that at all. I would just have IntelliSense figure it out for me, and then at the end of it, we'll have that would have been bad. So I'm going to generate three constructors. First constructor is going to take an object. The second constructor is going to take in a enumerable of values. And it's going to call toList to convert it into a list. And the third constructor is going to take in an iDictionary of that. I just confused resharp. I'm really confusing resharper. Then we're going to do a toDictionary kv.key, kv.value, just so we can copy it out. And I guess we can also just make this an enumerable of key value pairs, and that works too. The second thing I'm going to do with our value impl, and the reason I called it value impl, by the way, was because I didn't want to confuse it with the value property. And nobody's going to see the value impl type anyway, so I'm just going to make it internal. Doesn't matter. Then finally, our indexers are going to be very straightforward. We're going to say return return index is smaller than array.count array index, or null, and we'll talk about null in a second. Our our object key value pair, or our object indexer, is going to be a little bit more complex, because we're going to say I value value, and then we're going to say return object try get value key out value. If that works, return value. Otherwise, return null. So what is null? Null is going to be, because I want this never to throw an exception if you access an undefined property. I want this to be as very straightforward as possible. So I'm going to define a private static read-only I value null, which will be null. The reason I cast null to an object was so that there was no confusion as to which overload it should use, because otherwise it could get confused with these two overloads, because null can be applied to either of them.
Mm-hmm.
Also make sure that you have static there. One time I accidentally didn't have the static there, and I didn't realize it wasn't there, and it actually threw a Stack Overflow exception, which wasn't caught by the debugger because it's awesome. It actually crashed Visual Studio multiple times.
Oh, wow.
And the reason that is because this initializer resulted in the initializer of the object it created, which results in the initializer of the object it created, which results in the initializer of the object created, which, yeah, that was bad.
Awesome.
So make sure that this is static. Okay, so now we have our very, or not yet, we almost have our very a forgiving value. Because even if you try to access a key that doesn't exist or an index that doesn't exist, we'll just get back this null guy. But we want to make sure that we actually instantiate our dictionary and our lists on the actual constructors that concern them. The last thing I'm going to do is I'm going to have iValue implement IEnumerable of type iValue, so that we can for each over everything in the iValue. And this is simply going to return, get enumerator is simply going to return array.getEnumerator. Very simple. So here's our iValue. There's no way for us to, at the worst case scenario, if something doesn't exist at some point, it's just going to continue on and return a null value. And that's exactly the behavior we want. So now, how do we actually get our builders to return our nice little value implementation class? Well, we'll start with our constant builder, because this is going to be very simple. Simply need to return a new value impl and pass in our constant. Very simple. So this is the lowest level, no nesting. Our array builder is a little bit more complex, because we're going to be returning a new value impl, but we're going to be passing in the result of all of the sub-builders. So we do builders.select, and then we grab the build value, the result of the build operation for each of the child builders. For our object builder, it's going to be a little bit more complex still, where we're going to return a new value impl, and we're going to pass in builders.toDictionary, get the key, which is going to be just kv.key, and get the value, which is just going to be kv.value.build. So at this point, now when you call build on any of our builders, we'll get back this nice little value impl class or object, which we can use to do cool stuff with. So I'm going to go ahead and change the return type of our run method to iValue. And I'm simply going to return builder.build. So remember, builder is going to be, not you, builder is going to be our top level builder object that gets set to whatever the value is. So then I'm going to say var value equals parser.run, and now let's go ahead and do something cool. Let's go ahead and say console.writeLine value. Let's access the hey key. Then let's access the second item in that array, followed by the whoa key, followed by, I don't know, the third item in that array. And then finish it off with .value. So if we did this right, we should have selected this value out of here. Hit F5. And hey, look at that.
Nice, very nice.
So if we expect our value object, we'll see that it actually is representative of our entire JSON structure. Well, of course, not that, because, yeah. So this is an object that has, an array and so on and so on. Also, if we wanted to, for example, iterate over every item here, we could simply say, for each var val in value at hey, at the third index, at the key of low, console write line val. And of course, we have to do val.value. And what do we get? 2, 4, hey, or, oh yeah, hey's the output on 27. So we get 2, 4, hey, 2, 4, 3, 2, 4, 3, 2, 1, 2. And then, of course, we have a parser problem right here because I forgot a comma. And then you saw Antler, recovering very nicely.
Nice.
So then we get the rest of that, 515. So speaking of error handling, we're not going to be worrying about that really. There are situations that would crash this program, like this. But we're not going to be worrying about that really. I just wanted to show, or at least showcase, first of all, some Antler features. We looked at header, we looked at members, we looked at return types, we looked at dynamic scoping, we looked at multiple alternatives, we looked at actions, we looked at getting data out of tokens. We looked at aliasing out rules into variables. And yeah, so we looked at a lot of awesome stuff, and we also saw how we can take an Antler grammar and perform an awesome action with it without having to write any of the parsing and lexing code ourselves. So that allows us to simply focus on the actions we want to take when a particular pattern is matched within the Antler system.
Very cool. Okay, so is that pretty much everything for this example?
Yeah.
All right, well, ladies and gentlemen, with that, that will conclude this video. Thanks a lot.